Hello everyone, welcome to Coders Camp. We are at 14th day of December LeetCode challenge, and the problem we are going to cover today is range sum of BST. So we are given a root of binary search tree and two integers low and high as our input, and we have to return the sum of all nodes with the value of range from low to high. So let's understand this with an example. So here is our given binary search tree input, and we have to sum all the numbers which are in range low to high. So here the low to high value given is 7 to 15. So we have to pick the numbers and add the numbers which are between 7 to 15 and return our results. So let's start adding our values starting from the root node. The value is 10, which is in the range 7 to 15. So let's add 10, and then the next value is 5, which is not in the range. So the other value is 15, which is actually exactly in the range. So plus 15, and goes down, we can see 3, which is not in the range, and then add 7. And finally, we can see 18, which is also not in the range. So the overall sum is going to be 32. So how do we approach this problem programmatically is we have given a binary search tree. So it is very easy to iterate or traverse the binary search tree with any traversing technique and check whether the value is in the given range. And if it is in the given range, you can add that to a sum. It is a very simple and straightforward approach, and it is also an easy category problem. So this also runs in big O of n time, as we are traversing the binary search tree once and finding the value and adding up the sum. But you can make it better because there is a particular reason the input is given in the form of binary search tree. So the property of binary search tree is that every left node will have the values less than the root node, and every right node will have the value greater than the root node. So by using this property, we are going to check only a certain number of nodes and skip if we tend to know that these nodes are no longer valid. So let's start from the very first node, which is 10. So since 10 is in the range 7 to 15, and which is not less than 7, which means both the left side and right side of this node might have values which falls in the range. So we are going to traverse both left as well as the right side. So coming to 5, when you see 5, 5 is not in the range, so we are not going to include this value. But at the same time, all the nodes which are going to exist below to the left side of the 5 are definitely going to be less than 5. So in that case, if 5 itself is less than the lower range, then all the values which are in the left side to 5 or left child to 5 will also be less than 5. So in that case, we don't have to really traverse the nodes which are left children to or left side subtree to 5. So since left child are having lesser value, we skipped it, but the right side might have a larger value than the root node. So checking on the right value, 7 is the value and 7 is greater than 5, which also falls under the range. So we are going to add this value. So coming to the right side of 10, which is 15, because we don't have any more nodes to explore here. So coming to 15, 15 is actually in the borderline to 15. So the values which are in the right side can be more than 15. So we don't really have to look on the right side, but still, what if 15 lies directly in the right side? So we can give it a try. So the next node is 18, but which is not in the range, so we are skipping the value. Also, whatever is there right side to 18 will also be skipped. So we don't have any more nodes left to iterate. So we have added the enough value which fall under the range, and we are going to return the result. So it is very simple technique that if we find a value which is actually less than low, then we are not going to explore the left side. Or if we find a value which is greater than high, then obviously we are not going to explore its right side. So that's it. Hope you're understanding this concept. Let's go to the code now. So as I said, we are going to check if a root value is less than the lower limit itself, then there is no point in exploring the left child of that tree. So we are simply going to traverse the right hand side of the root node and proceed the sum from that. So we are going to use an recursive technique to call the nodes and traverse them. So simply, as I said, we are going to call only the right children of the root node. Same way, we are going to check if the root value is greater than the high limit, then we are not going to explore the right children of that root node and simply going to only traverse the left children of that root node. And finally, we are going to return the sum of all. Yes, that's it. And we have to check one more base condition, that if the tree itself is null, then return 0. So yes, let's run and try. Yes, so let's submit. Yes, the solution has been accepted and it runs in 0 milliseconds. So thanks for watching the video. Hope you like this video. If you like this video, hit like, subscribe, and let me know in comments. Thank you.